what the 2025 spider crop circle reveals. When people start making crop circles, it's common to rely on many construction lines, guide circles, symmetry axes, visual markers to position the design's elements. But if these lines remain visible once the formation is complete, they interfere with how the final pattern is read. This is exactly what happened with the spider formation that appeared in 2025. Its legs and fangs required extensive preparatory tracings, all of which were flattened into the crop. The result is a cluttered structure, with overlapping arcs visible in front of the spider, disrupting the overall design. This kind of complication mainly arises when the design extends beyond the central circle, as it does here. The long legs stretch far from the main body, so to draw them precisely, operators must rely on large guide circles around the edges. But once the legs are flattened, these lines remain, exposing the entire construction process. By contrast, more compact designs like those seen early in the 2025 season allow preparatory markings to be integrated into areas that will be flattened anyway, making them easier to hide. In that sense, the geometry of the design plays a key role in whether such traces are visible or not. But how is it that some formations leave absolutely no visible trace of planning, as if they were projected in a single movement without guides or sketches? This has led some researchers to consider more discrete technological tracing methods, possibly invisible to the naked eye. But so far, no direct observation or documented evidence confirms the use of such techniques in the fields. It all remains hypothetical. Still, the idea that advanced human technologies could create designs remotely is as intriguing as it is puzzling. Why do it? To fool observers? To test a secret process? To stage an unannounced global demonstration? Or even to open a hidden dialogue, an interaction with the real phenomenon? In the case of the spider, another reading is possible. Those visible construction lines might not be accidental errors, but deliberate marks, as if someone wanted to show, even prove, that the formation is human-made. In that case, it would be a form of soft disinformation, a way to plant the idea that this is all just a game, a bit of homemade tinkering, nothing mysterious or meaningful, a subtle but effective deterrent. The perfect counterexample: the 2004 bee crop circle. In stark contrast to the spider design filled with visible lines, the bee crop circle that appeared in 2004 demonstrates a radically different level of precision. The pattern is complex, detailed, and sharp, yet no construction lines can be seen around the design. No straight arcs, no geometric guides left in the field. The bee stands out cleanly, almost as if cut directly into the plants themselves, with no visible clues as to how the makers managed to place each element, the body, head, wings, outlines, orientation, with such accuracy. Everything is there and nothing around it. This total lack of peripheral marks raises a simple question: how was such a complex pattern created without visible guides? And what about that? Imperfect symmetry. One detail stands out. Unlike many other crop circles built on strict geometric symmetry, the bee formation is not perfectly symmetrical. But is this really a flaw, or could it be a clue? In this type of design, asymmetry might not be an error, but a key, a way to draw attention to a specific detail, a direction, or a deliberate imbalance carrying deeper meaning. A separate article will explore this question in greater depth, examining how non-symmetrical geometries in crop circles might actually be trying to signal something through their apparent imperfection. It's also worth recalling that a strange nocturnal phenomenon was reported in the exact area where the bee appeared: silent, colored, and unexplained. Is it connected to the formation's arrival, or just a coincidence? Forgotten infrared methods. In 2011, Rebecca Boyle published the article "Creating Crop Circles with Lasers and Microwaves" on her website. It features an interview with Richard Taylor, University of Oregon, physicist, USA. Background: In the 1980s, physicist Richard Taylor, a specialist in visual perception, took an interest in the emerging crop circle phenomenon. He observed that the designs were becoming increasingly complex. The idea that a few pranksters with planks could create these structures soon seemed implausible. Some formations contain hundreds of elements, laid out with a level of precision that's hard to explain using basic tools. Taylor chose to investigate the phenomenon with a scientific approach, working hypothesis. Taylor suggested that some modern crop circles might be made using advanced human technologies, combining portable microwave devices to bend stems without breaking them, lasers to trace perfectly straight lines, and GPS systems to accurately reproduce computer-generated designs. He also suggests that these technologies could be mounted on an autonomous drone capable of following the design path with precision. The drone would act as a mobile platform, emitting a localized microwave beam to heat the plant nodes and bend the stems without breaking them. This process would allow for a discreet, fast, and hard-to-detect method from the ground. It wouldn't involve a beam fired from space or any long-range device, but rather a localized, low-altitude emission guided by GPS or autonomous control. While Taylor doesn't claim this method is actually being used, he believes it could account for certain anomalies observed in the field. How microwaves work. Cereal stems contain nodes. When exposed to microwave radiation, these nodes heat up, swell, and bend. The stems then lie flat without breaking. Once cooled, they remain in position. According to Taylor, this method would be more efficient and less detectable than traditional stomping. Field analysis has reportedly found signs of localized heating on some stems. This technique only became feasible with the recent development of portable, battery-powered magnetrons, removing the need for bulky generators. Suggested methodology. The hypothetical process Taylor outlines includes designing the pattern on a computer using architectural software, converting the design into GPS coordinates, sending this data to a field operator equipped with GPS or a GPS watch, using a laser to mark the lines for accurate positioning, heating the stems with microwaves to bend and lock them in place. The ground artist set perspective. John Lundberg, a crop circle maker interviewed in the same article, dismisses the microwave hypothesis. He states that he uses only simple, traditional tools, wooden boards, measuring tapes, ropes, and software like AutoCAD to draft the designs. He explains that symmetrical patterns are favored because they are faster to execute, while asymmetrical ones take much longer to produce, which could explain why they are so rare. He also criticizes overly technical theories, calling them unfounded speculation or pseudoscience. Taylor's motivation. Taylor says he wants to give credit to the creators of these works, whether human or not. For him, explaining a phenomenon doesn't diminish its beauty. He compares it to his analysis of Jackson Pollock's paintings. By showing that Pollock's works contained fractal structures, he helped highlight a level of artistic mastery that was often overlooked. He hopes that by identifying the possible tools used to make crop circles, we might eventually acknowledge the skill and precision of those behind them. Evolution of technologies between 2011 and 2025. Back in 2011, consumer drones were still in their early stages. The models available were mainly used for aerial photography without any ground-guided systems or projection capabilities. Advanced technologies like infrared line projection, visible only through specialized goggles, were mostly limited to military or high-security surveillance applications at the time. In other words, if such a system had been used back then, it would have required considerable resources, access to specialized drones, sophisticated projection equipment, and flight authorization, the kind of setup typically reserved for institutional players or very wealthy individuals. By 2025, the situation has changed. Programmable drones capable of projecting shapes or beams onto the ground have become much more accessible. The hypothesis of an infrared pattern projected onto a field, discreetly followed by a ground team equipped with adapted goggles, is now technically feasible, without the need for heavy infrastructure. This shift in technological context makes it possible to revisit certain methods once considered overly complex or unrealistic. Now seen as simpler, more effective, and above all, more discreet than those suggested in earlier years by researchers like Richard Taylor. A complementary hypothesis: aerial firing from a stationary airship. Other variants, not discussed by Taylor, also circulated during the 2000s. One aerial hypothesis suggested the use of stationary, silent airships stabilized by gyroscopes, capable of emitting a coherent beam, thermal laser, or microwave maser to form patterns on the ground. These aerostats, potentially of military origin, could operate at high altitude discreetly, using infrared, radar, and GPS systems. The plants would be altered remotely, with no need for humans on site. Some American research programs, such as HAE, High Altitude Balloon Experiment, have explored similar systems designed to stay aloft for several days and aim precisely at ground targets. This hypothesis, proposed in the early 2000s, could explain both the speed and precision of some formations, without requiring any physical presence in the field. However, it has never been publicly demonstrated. Technological context. This evolving technological context makes it possible to reassess ideas that once seemed too expensive or too complex. And yet, the option of infrared-guided drones, never mentioned in the 2010s, now appears far less sophisticated than Taylor's GPS plus laser microwave scenario. It requires no military logistics, no direct radiation on the plants, and no heavy equipment. It's a discreet, lightweight method that can be carried out entirely in the field, without involving governments, satellites, classified devices, or billionaires. Lodging dynamics, directed flows, and invisible control. Lodging refers to the bending of plant stems due to wind, rain, or their own weight, a well-known phenomenon in agronomy. But in the case of crop circles, it takes on a whole new dimension. Some formations display characteristics that go far beyond the ordinary. The stems aren't just flattened chaotically. They follow a fluid, almost choreographed arrangement, as if a specific current had passed through the field along a defined trajectory. Field researchers, such as William from the Culture Crop website, have documented this dynamic in several formations. He describes flows similar to currents of water or air, which follow the shape of the design. In the case of the bee crop circle, a troubling nighttime observation was reported. A reddish vortex, resembling a cloud cone pointing toward the ground, was seen hovering above the field just hours before the pattern was discovered. A few hours later, at dawn, the crop circle had appeared, intact, with no visible sign of entry or human presence. On site, the stalks appeared to be swept down rather than broken. The bloom, that fine, waxy layer naturally coating the plants, was still present, a key indicator of the absence of physical handling. Even in the most densely flattened areas, no trace of mechanical or human trampling was visible in the early hours. What kind of technology could be behind this phenomenon? What if an unknown technology could channel localized aerodynamic flows, capable of bending stalks at a distance without mechanical contact, lasers, or microwaves? In this case, it would not be a simple directed tool, but rather a form of mastery over the natural elements themselves. As if an intelligence knew how to control air movement precisely, adjusting pressure, direction, and speed to shape the pattern without touching it. A technological beam, whether laser or microwave, even when highly precise, acts along a single trajectory from a fixed or mobile point. It strikes a surface in one direction. And yet, many crop circles display the opposite dynamic. The stalks appear to have been pressed down by multiple simultaneous flows, as if converging air currents had sculpted the forms from several directions at once. This kind of result suggests not a simple beam, but a multi-directional management of spatial flows, as if the air itself had been precisely mobilized to carve the formation. This contrast invites broader reflection on the very nature of the phenomenon. It raises a crucial distinction. It's one thing to bend stalks in straight lines using a directed beam. It's another to generate fluid, undulating, organized currents capable of gently conforming to a complex shape. Could this be a technology capable not just of bending, but of orchestrating? Without invoking subjective notions often tied to frequencies or energy, this hypothesis raises a concrete technical question. Between the precision of a microwave beam and the subtlety of a perfectly directed air current, which of the two would represent the more advanced level of technological control? Beyond the method, meaning. Whatever technologies are used, boards, lasers, microwaves, drones, or airships, one piece of the puzzle is always missing: meaning. A crop circle cannot be reduced to its method of creation. We must also ask what it communicates, what it anticipates, or what it responds to. Some patterns appear in sync with major global events, others seem to encode a future scenario or are placed in locations of geographical significance. These aspects do not stem from technique, but from a form of narrative intelligence, capable of aligning a pattern's appearance with a precise context, whether historical, geopolitical, astronomical, or symbolic. In other words, the study of technical means cannot be separated from a broader analysis of the pattern, its content, and its placement within a larger context. This is where another kind of investigation comes in: a more holistic approach, that is, a global perspective that takes into account material, symbolic, and contextual aspects, where physical data alone is no longer sufficient to explain the phenomenon. Such an approach requires a shift in perspective, no longer focusing solely on how a pattern appeared, but on why it appeared there, at that specific moment, in that particular form. This implies combining several disciplines: geometry, to understand the internal structure of the figures; astronomy, to check for possible celestial correspondences; geography, to examine spatial alignments or coincidences; history, to place the pattern in its time period; and finally, symbolism, to interpret what the design evokes, suggests, or reflects within the collective unconscious. From this perspective, a crop circle becomes less of an object to be manufactured and more of a message to be deciphered. And this message, if it exists, can only be revealed by considering all the superimposed layers: matter, form, location, timing, and human perception. It is therefore a multidimensional investigation, where the technician, historian, artist, physicist, linguist, and anthropologist each have a role to play. To illuminate this cross-disciplinary approach, it may be helpful to clarify the role each discipline plays in such an investigation. The technician assesses technical feasibility. Can this pattern be made with known tools? How long would it take? The historian places the pattern in its historical context. What was happening at the time of its appearance? Are there echoes from other eras? The artist analyzes the composition. What is the visual strength of the design? What emotions or impressions does it evoke? The physicist examines physical anomalies, bent stalks, electromagnetic residues, measurable disturbances. The linguist studies structures and recurring forms and tries to discern a symbolic language or syntax. The anthropologist observes human reactions. How is the pattern perceived, interpreted, ritualized by the societies or groups that encounter it? This convergence of perspectives does not guarantee a single answer, but it enriches the reading of the phenomenon. It is therefore an investigation that cannot be resolved solely in the field, but also in understanding our era, its thresholds and turning points. From this perspective, crop circles are no longer just a surface phenomenon. They become deep markers, perhaps even interfaces, between our material world, our belief systems, and a still unidentified form of intelligence. While the hypothesis of human technologies, infrared, lasers, drones, balloons, remains plausible for some formations, many gray areas persist, especially when no evidence of intervention is visible in the field. No access marks, no construction lines, no crop damage. This has led some researchers to consider another possibility: an intelligence capable of harnessing natural forces already present in the fields. wind, pressure, waves, without relying on any identifiable mechanical or electronic device. If such a level of intervention exists, it would be far more advanced, as it would rely on invisible yet real dynamics, detectable only through certain observations. Such intelligence no longer seeks to display its technology. It acts through natural conditions, and perhaps it is this apparent technical silence that is most disorienting.